In this question, from the statement in the question, we know the expression of zt, which is this, and we can also we know the theta is a random variable and it is uniformly distribution. It's a uniformly distribution between 0 and 2 pi. So we know the PDF of theta. And we also know that the N1T and N2T are WSS. So we know the expectation of N1T is eta 1 and the expectation of N2T is eta 2. And also the autocorrelation of N1T is Rn1 tau, and the correlation of N2T is Rn2 tau. And so in the A question, we want to calculate the expectation of zt, and we can because we have already know the expression of zt, so this part equals to the expectation of n1t multiple cosine omega ct plus theta and plus n2t multiple cosine omega sin omega ct plus theta. And we can expand this expression. It is equals to two parts, the sum of two parts. First part is expectation of n1t multiple cosine omega ct plus theta. The second part is the expectation of n2t multiple sin omega ct plus theta. And for the first part, and because the n1t and n2t and theta, they are independent. And so this part, it is equals to the expectation of n1t multiple the expectation of cosine omega ct plus theta. The first part, this part is obvious that it is equals to eta 1. This part is the integral from 0 to 2 pi cosine omega c plus theta, omega ct plus theta multiple the probability density function of theta, d theta. And because the theta is uniformly distribution, so it is equals to, this part equals to 1 divided by 2 pi. So it is equals to n eta 1 divided by 2 pi multiple 0, the integral from 0 to 2 pi cosine omega ct plus theta, d theta. And it is obvious that from 0 to 2 pi, it's a period of this function. And because it is cosine, so in one period integral, it is equals to 0. So this part, it is equals to 0. Also, we can using the same method to calculate the second part, n2t multiple sin omega ct plus theta. And this is equals to n2t multiple e cosine e sin omega ct plus theta. And it is equals to, this part, it is equals to eta 2, and the integral from 0 to 2 pi sin omega ct plus theta multiple f the probability density function of theta, d theta. And this part is equals to 1 divided by 2 pi. So this is eta 2 divided by 2 pi 0 to the integral from 0 to 2 pi sin omega ct plus theta d theta. And it's also obvious that this part it is equals to 0. So the whole part is equals to 0. And then we so we know the expectation of zt, it is 0. So this is a question. For the B question, we want to calculate the autocorrelation of z, and using the definition we can write the calculation and using the expression of zt we can write this autocorrelation for expression, and it should be this. And when we expand this part, we can obtain four parts, which the format it is obvious that this format is product. And because the product is hard to calculate, and we can using these four formulas to substitute the product. And for the first part, it is equals to the expectation of this. And because the N1T and N2T and theta, they are independent, so we can write this part into this format. It is equals to the expectation of N1T1 multiple N1T2, and then multiple the expectation of cosine omega ct1 plus theta, and multiple cosine omega ct plus t2 plus theta. And the first part we can find that it is the definition of the N1 the autocorrelation of N1T, so it is equals to the Rn1 tau. And the second part we can using the first formula to substitute the product by using the sum or subtract format, and this part can be written as it is this the whole expression is equals to 1 divided by 2 R1 tau. We can let the T1 multiple T minus T2 equals to tau, and it is equals to, and then multiple integral from 0 to 2 pi cosine omega c multiple the sum of T1 and T2, and then plus 2 theta, and then multiple cosine omega c T1 minus T2, and because this part is equals to tau, so we can substitute it with to tau, cosine tau, and d theta multiple the probability density functions of theta and d theta, And because this part it is equals to 1 divided by 2 pi, so we can calculate this part. It is equals to 1 divided by 2 Rn1 tau multiple 1 divided by 2 pi, integral from 0 to 2 pi, cosine omega c multiple the sum of T1 and T2 plus 2 theta d theta. And because this part is now business with theta, so this part can it equals to 1 divided by 2 pi multiple 2 pi multiple cosine omega c tau. And it is obvious that this part is equal to 1. So this part, so it is the first part equals to this. And using the same method and we can use the formula 2 and formula 3 and formula 4 to substitute the product, and we can get the final final expression of the correlation, which should be this. Rz T1 T2, it is equals to 1 divided by 2 Rn1 tau 1 divided by 2 pi integral from 0 to 2 pi cosine omega c T1 plus T2 to theta d theta and plus cosine omega c tau. And this is first part, and second part is 1 divided by 2. And the expectation of N1T1 and N1T and N2T we have already know is eta 1 and eta 2, so we can using this conclusion to calculate the second part and the third part, which is equals to this 1 divided by 2 pi integral from 0 to 2 pi sin omega c T1 plus T2 and plus 2 theta d theta and plus sin omega c tau. And third part is 1 divided by 2 eta 1 eta 2 1 divided by 2 pi integral from 0 to 2 pi sin omega c multiple T1 plus T2 plus 2 theta d theta and minus sin omega c tau. And the last part is minus 1 divided by 2 Rn2 tau and multiple 1 divided by 2 pi 0 to 2 pi and cosine omega c T1 plus T2 plus 2 theta d theta and minus cosine omega c tau. And when we expand this the whole expression, we can find this four part, the sum of these four part, it is equals to 1 divided by 2 Rn1 tau plus Rn2 tau and cosine omega c tau. And it's obvious that it is equals to Rz tau. And because expectation of zt, it is equals to 0, and the correlation of this are z tau. So it is obvious this the zt is WSS, and this is a B question. For the C question, and when tau is equals to 0, RZ0, using the conclusion above, we can know this equals to 1 divided by 2 multiple Rn1 0 plus Rn2 0 and multiple cosine omega c multiple 0, and this part is equals to 1, so it is equals to 1 divided by 2 Rn1 0 multiple Rn2 0. And because we have already and because this part, it is equals to the when tau is equals to 0, we can write this part into this format. And plus the expectation of n2 t to the power of 2. And so this is the C question, and this is the 7th question.